Did you know that the first GPS satellite, the first GNSS system to be freely used by civilians, was first launched in the United States in 1978? And it wasn't available for global use until 1994. I can only imagine how much easier our family car trips would have been had my family had the GPS we have now, instead of those coffee stained maps that never seem to get folded correctly. Today, GNSS is used in a wide variety of applications, including power tools, drones, and asset tracking. And it's that last use case that we're going to zoom in on today: asset tracking, from fleets of vehicles to scooters and wheelchairs. We've got miles to cover, my friends, so we better get started. Hi, I'm Amelia Dalton, host of Chalk Talk. In this episode of Chalk Talk, Arnaud Le Lannic from u-blox, Greg Makar from the YAGEO group, and I explore the benefits of GNSS for general precision location tracking. We investigate the biggest challenges associated with these kinds of designs, the solutions best suited for vehicular asset tracking, and the mounting options available for these solutions. And before we get started, don't forget to click that link. There you can find even more information about this topic. Hi, Arnaud. Thank you so much for joining me.
Hey, Amelia. Thank you for inviting us to join today.
Absolutely. And hi, Greg. Thank you for joining me.
Thank you, Amelia, for hosting.
Absolutely. Okay, so Arnaud, we're looking at an evolution within the implementation of GNSS today. What are some common use cases for GNSS? And we're talking about meta level accuracy use cases here, right?
Right. So let's start from the beginning. So the first kind of market GNSS application were used for in, let's say, consumer or private areas was what we call aftermarket telematic. It's a kind of application where all of us had a PND sticked on the windshield into our car to help us drive around the city or go from A to B. And meanwhile, this kind of application have been integrated in the vehicle or in mobile application. On the industrial side, this aftermarket telematic was mainly targeting owner of vehicle fleets, as well as tolling for heavy vehicle commercial application. And this was really driving the first use case and application in terms of GNSS. Nowadays, GNSS is really everywhere, and most of us make use of multiple GNSS receiver during their typical journey. So we could start with applications like drones, which are now really enabling new use cases where the GPS enables the autopilot function or geotagging of filmed made events. On the professional side, this GNSS on the drones are really important for delivery, surveillance, photography, and this really revolutionized the use case of drones application. Then you see as well, for example, there are this portable world. We use more and more portable devices, tablets, laptop. This also is really a game changer, enabling mapping of activity done for professional or enabling location-based services when you look for your location or you look for travel or some location you want to go. Having the possibility to know where you are when you do the search is really enabling new use cases. In mobility world, bicycles, for example, private mobility, anti-theft, lock, stolen recovery of vehicles, fitness tracking, navigation for cyclists exploring new routes, or in case of micromobility, what we call shared micromobility, about bike sharing or e-scooter sharing, all these services rely on GNSS. You also have the use case of parking spaces. Today, it's really much easier to be able to locate parking spots in cities where maybe the circulation is packed or all the parking slots are really busy. This enables us to optimize really the urban mobility. More on our private levels of every day, if you guys have a pet at home, it's becoming really comfortable to know where your dog or cat is locating when they walk by themselves around the house, around the property. And it's also enable you as well to get a bit of information how your pet is going. Is he moving regularly? What kind of distance is he doing every day? And to monitor as well the well-being of your dear friend. So pet is going with you, and about yourself is the same. Many use cases enabling you to practice sports, hiking, or professional athletes which are willing to know precisely and automatically monitor their performance and exercise session. GNSS is really enabling to collect precisely and monitor automatically all these activities. And you as a private as well, if you want to prepare sport events or share tracks of your activity with your community, GNSS is really a game changer, enabling you to get precise track of everything you do and help you prepare your sports events.
So, Arnaud, what u-blox solution would you suggest using for these kinds of use cases?
Typically, for this kind of use cases, we have what we call a portfolio of products focusing on standard precision GNSS. And I think the typical use case we have here for this kind of application is our product called the Max M10, which is our kind of all-around product in that respect, because it's really polyvalent, offering all the need to secure the best GNSS performance. It's about 10 by 10 millimeter module, which come with most of needed features. It's already quite small, even comparing to other kind of product we might have. It's easy to handle for evaluation as well as for manufacturing. What is also important looking at the Max, it's allowing very good power consumption compared to our previous generation. We talked about 75% less power consumption without compromising the performance. Actually, the performance are getting improved because on this generation, we can track up to 4 satellite constellation. So not only GPS that everybody knows, but as well as constellation like Galileo, Baidu, and GLONASS are supported by this kind of receiver, which enable really better access to satellite even in challenging environment and automatically improve the performance of the receiver and the user. Last but not least, what we brought with the Max is a true position indication, which we called the protection level. Traditionally, the receiver of u-blox allows the customer to judge the quality of the provided position thanks to what we call the accuracy estimate, which is basically an indicator about the radius of a circle centered at the aim point having a 50% probability of hit. This was good enough for many applications, but the demand for more quality and more deterministic information led us to work on that we call the protection level, which basically provide you a 95% probability of hit and therefore a much better information on the confidence of the current condition. So this is a key enabler for good geofencing implementation, for example.
So, Greg, let's talk about vehicular asset tracking. Can we walk through what that would look like?
Well, sure. Well, Arno pointed out some of the past use cases and even some of the more current evolving use cases for vehicular asset tracking in particular. We're seeing a shift from just using GNSS for an original purpose of figuring out where you're going, figuring out where you are now, figuring out where your destination is and how to get there. We're seeing it more used for that as that where they're tracking. Maybe you have a fleet of expensive vehicles. Maybe you're a rental company, for example, and you want to make sure you know where your vehicles are at all time, not for the purpose of getting them to their destination, but to make sure that you haven't lost that valuable item for yourself as part of your company. So we're starting to see this become more and more common in the vehicular space. It's been around for some time because of the value and the expense for these kinds of items. You'll see tracking maybe utilized at a trucking company for seeing how fast the driver is going for safety purposes. There's a variety of use cases that pertain to the vehicular market that are a bit unique, but also will bleed into the other types of asset tracking we'll see external to the vehicular space. And vehicular space gives us a nice integration into looking at GNSS in general. Because of how large they are, they actually give us a lot of benefit and positioning, both from not having to worry about very detailed centimeter precision to the fact that we have to utilize antennas to get that actual signal from the satellite for the positioning. And when you have a large vehicle to utilize for that antenna, that's easier to do.
Okay, so Greg, what kind of mounting options do we have here?
Right. So I talked about how at the end there, that large vehicle offers you a better performance for an antenna per se, It makes it easier to track something, even something that's large. So in the first place, you don't need to have such precision centimeter level. But even then, at a meter level, because it's large, it gives you better performance from an antenna. Why is that? Well, these antennas that are being used for vehicle tracking are almost always mounting on that metal surface, that rooftop of the vehicle. We see that in magnetic mount options that just are placed directly on the metal surface and stay there. We see these in a permanent mount where you have to place a hole through the metal, but then you can put in the antenna permanently, more fixed position. So that's why these antennas can perform so well and get a strong positional accuracy to work with the radio in tracking vehicles in particular, being how large they are, and they offer a large ground plane for these magnetic and permanent mount antennas. That said, you also have a couple of other options for antennas in general at the vehicular level. Another one you might see is an adhesive mount. An adhesive mount antenna can be similar to a magnetic mount that you've placed on a rooftop. It also might be one that you've placed inside a vehicle on a dashboard, on a glass surface. It doesn't necessarily require a metal surface. And that may change some of what we've talked about when it comes to getting that stronger positional accuracy with the assistance of that metal ground plane underneath the antenna. But having those options is key for a variety of reasons. Some business cases may have reason to choose something that doesn't leave a permanent hole, for example.
That makes sense. So, Greg, are there any other vehicular asset tracking options?
Well, we've talked about some of the three probably key use cases there. You might also utilize a device that will be installed separately, a housing and an antenna on a PCB that's part of something being sold to this company that isn't being installed directly by it. And that's another use case. We'll probably look at some of the other internal antennas instead of these external ones. For these external ones, a bit more detail that we didn't really touch on as far as performance goes and some consistencies we typically see throughout them. We talked about GNSS, and Arnaud pointed out the different satellite constellations. And of course, these are always designed to make sure that worldwide they'll be picking up the satellite of choice in the region. They're also typically designed to have two stages of 15 dB gain LNAs. Sometimes they're designed with 20 dB gain stage LNAs. Very commonly, these outdoor vehicular antennas aren't relying on the radio and the design there to add those LNAs. Obviously, there are cases where that radio does provide that, but very commonly we see that used on the antenna side of things, which makes them very consistent when choosing whether you're going to go with a permanent or magnetic mount, for example. And of course, we haven't spoken so much about polarization. These are almost always designed to be right-hand circularly polarized. The satellites use right-hand circular polarization. There are a lot of benefits to this when coming from a satellite for picking up the signal. There are benefits in terms of multipath rejection when the signal maybe is reflected off mountains, for example. There are benefits for direct gain when the polarization matches. So there are reasons these antennas are designed in this case. But there are also some reasons they might not be right-hand circularly polarized. They might be different. If they're internal to a device, we might not see these two-stage gain LNAs included. There's a variety there of different products utilized in the vehicular market.
So, Greg, when it comes to a magnetic external mount, what would that look like?
You might see that used in a rental market, for example. Maybe some company that rents vehicles or rents some type of product doesn't want to leave a permanent hole in the vehicle rooftop because they'd like to sell that vehicle later, for example. So it would give them a good reason to take one of these antennas that you can simply place on the metal and it will stay there. They're very strong magnets, of course, so that you don't have to cause any kind of permanent damage to the asset you have. It might make it more resellable in the market. That can be very common for that use case. They tend to be low profile as well, so it can be nice to keep it something a little bit harder to see. Probably the most common reason you might think to utilize a magnetic mount to make sure that your asset itself does not have any kind of permanent damage, so you might be able to move it or sell it later. They're very plug-and-play solutions, of course, as most of these are. It's very easy to stick a magnet on a metal surface and then simply route your cable. So you might also see this for easy install for trucking companies, things like this.
That makes sense. Now, you also mentioned permanent external mounts as well. So, can we also talk about those?
Right. Well, there are some vehicular cases where the magnetic mount might not be something you trust, really, for example. Maybe it's a high vibration environment. If we're speaking about construction vehicles or other heavy equipment, a magnetic mount might be something that you're fearing, as strong as the magnets are, will come loose, will shift. You've got reason then to make a hole in a metal surface somewhere on this vehicle and install the antenna such that with a nut in the back, it won't move. There are definitely cases where you have to worry about a magnetic mount not being strong enough. You might not be worried about that for vehicles that are simply driving on the road, but in cases where you actually have heavy duty equipment, that can be a real concern. There's also the aspect we like to call them as tamper proof. I mentioned that there's a nut on the back. You might have the kind of property that externally somebody could reach, and so you're worried somebody could try to steal an antenna. Theft is always a concern in the first place when it comes to asset tracking. It's one of the reasons you utilize a GPS GNSS antenna solution. For a variety of reasons, you're worried about somebody possibly taking your asset and walking away with it. And that can be true for some vehicles as well. Maybe it's a tractor in a field that somebody could perhaps reach and get to. And that's a reason you'd have a permanent antenna that can't be removed so that that tracking purpose, Arnaud talked about recovery, that can stay in place.
What about asset tracking on a smaller scale?
A lot of the same principles that fit in the vehicular market apply also on a smaller scale. And we kind of alluded to that earlier as well. So even smaller devices like a wheelchair or a scooter, for example, have a lot of the same principles. For one, there's still a case of making sure that your asset hasn't been lost in the world, that you know where it is, and that somebody can't simply walk off with it. You also don't want your antenna to be walked off with. There are a lot of reasons to be utilizing this application here as well. However, if it's a smaller device, you might not have what I mentioned as that large metal ground plane that helps an antenna perform better. So your antenna might not be external, it might be inside the device. Maybe you can provide it a ground plane there, or maybe you simply have to find some space for it and try to get the best performance you can. But a lot of the times in these smaller devices, the antenna is more hidden, especially if it's a consumer device as well. It might be the case that somebody utilizing the smart wheelchair or a little drone or robot doesn't want to see the antenna. It seems that antennas are not always something pretty these days. So these kinds of cases might see the antenna included inside. So you don't see it externally anymore. It becomes an internal antenna.
Fantastic. Now, let's talk more about these internal antennas.
Yeah, sure. Now, some of these internal antennas are going to be very similar in terms of their design and performance to the external antenna. It's still important in many cases to utilize LNAs directly packaged with the antenna. It allows designers to not worry about putting LNAs on their board, choosing SAW filters for themselves. A SAW filter is integrated into the antenna product. And if the radio is not being utilized to do that for you, it's important to include that. There's a long distance for the signal from the satellite to travel, so boosting that signal is an important part of a GNSS total package. So we try to make these as well easy to install, just as the external antennas are fairly easy to install, especially if they were a magnetic mount, for example. These tend to come with adhesive backing, so it's easy to stick them onto a surface. Typically, you don't need to worry about expanding that ground plane for them. They'll certainly perform better if given a ground plane to be mounted on, but the design is meant to perform well in its own little package. These antennas also can sometimes be customized. They're different sizes, but they have the same principles as what we discussed before in terms of LNAs, in terms of polarization, etc.
Fantastic. Now, what if the designer doesn't want or need LNAs to come packaged with the antenna?
Sure. Yeah, I kind of alluded to the fact that sometimes you don't need to do that because you're designing it yourself. You're happy to design those filters and LNAs yourself. And of course, sometimes the radio can handle that for you. You don't need to utilize an active solution, as we call them, that comes packaged with those LNAs. You can utilize a passive solution. And typically, especially as we're still talking about the right-hand circularly polarized antennas, they're going to look very similar as far as the actual antenna construction goes. You haven't really changed much there throughout this variety of antennas. We're looking at directional patch antennas for the most part. These are usually your go-to for GNSS. For one, right-hand circular polarization, as mentioned earlier, has a lot of advantages when it comes to long-distance signal travel, when it comes to dealing with multipath interference. Also, a directional antenna is excellent for these cases where you know where the satellite is in the sky, as it were. Sure, there's some movement there. Right-hand circular polarization has some benefits in terms of not having direct line of sight to the satellite. But these directional antennas, they've been taking part actually in all of these models that we've talked about so far. The idea is you've installed the antenna in such a location that it's always pointing up towards the sky. So you can get your best performance utilizing these sort of passive patch type antennas. Very commonly chosen for best performance. You don't require an active solution for it. You can simply use a passive solution with your own design on the board.
So, Greg, what if there's no clear line to the sky? What solution would you recommend in this case?
So there are certainly design cases where you're not actually sure what orientation device will be in with respect to the satellites. Now, There are some benefits still to right-hand circular polarized antennas, even when not directly pointed toward the sky. However, those antennas, like the patch antennas, often are also directional antennas, so there's a bit of loss involved when you're not looking in the correct direction if your device is installed such that it's upside down, for example. There are reasons then to go to something that's omnidirectionally radiating, or receiving in this case. For example, you can have a linearly polarized, flexible internal antenna that can go on the plastic wall of a housing somewhere. They're still very easy to install, similar to the active antennas discussed before internally. Doesn't mount directly on a PCB like a passive patch antenna does, but this passive solution still doesn't come with LNAs. You can install it without worrying as much about what orientation it will be in with respect to the sky. That omnidirectional reception pattern in this case for signal kind of is a trade-off with the fact that it ends up being linearly polarized, especially due to size. The linearly polarized antenna tends to be something you can make in a smaller package. So despite the fact that there are some give and takes, as it were, in terms of switching from a patch, directional, and right-hand circularly polarized to a linear flex antenna, it could be overall a winner if you don't know the orientation of your device with respect to the sky, if you might have it, for example, installed opposite. And we do see cases where a designer is making a product, they're going to sell to consumers who are going to install it. So that is an issue they have to worry about.
All right. So, Arnaud, what kind of applications are we talking about here?
Well, as Gregory mentioned, as we go, the design is very important. Not only the design, but the integration of the electronic into the design. Historically, the first devices were about tracking a vehicle, where space, weight, orientation of the antenna was rather trivial. As we go, the use cases are multiplying, and the need of having a device which integrates and fits to our use case, being a human tracker, animal tracker, an asset tracker, a bike computer, it needs to be small. You don't know where the antenna will be looking, in which direction the antenna will be looking. You don't know exactly where the GNSS device will fit, but it has to fit in a limited packages, which will, in most of the case, will have a limited space for a battery, enabling a relatively limited supply of any GNSS device. An asset tracker is typically very small. You don't want to see it. You don't want to feel it. So the battery has to be small. The antenna must be small. The overall design needs to be small, which implies the electronic has to adapt to the device and not the device has to adapt to the electronic.
That makes sense. Now, Arnaud, overall, what do you think are the biggest challenges for these kinds of designs?
To summarize, the biggest challenges for this kind of design is the size. The size of the package, as you see here, the cat is wearing a device on his neck. It cannot be big, otherwise it will not be accepted by the animal. The owner of the animal will find the design ugly. So it must be small. It is a challenge for us, RF guys, to get good signal reception. It is a challenge for our management. In a small device, you need to live with a small battery. And in a small device, you need to survive with weak signals.
So, Arnaud, can you talk a little bit about the Mia M10 and what this solution brings to the table?
Right. So in the scope of this use case and these challenges, what the Mia is bringing is first, it is bringing a unique size. It is the smallest GNSS module you will find on the market. Thanks to the fact that u-blox own is chipset, it enables us to provide a very small size of product. We selected a technology which allows us to make a module smaller than any discrete chipset design you would do on a standard PCB. So here the customer needs to select the antenna for his use case, fitting in his product, connect it to the receiver, and then only the tracks connect the receiver to the MCU for communication and power supply are needed to be added. The second aspect Maya is bringing here for such a use case and application is what we call the small antenna support. When the GNSS signal are touching the surface of the Earth, the amplitude is relatively low, which makes it really important to target the best RF performance into your design. The application requirements and conditions are known and in many cases as well relatively complicated. So dealing with limited signal is very important. With the Mia, what we brought to the market is a product which is able to deal much better with weak signal we estimate that with this new implementation, we are able to improve of about 25% the performance of the product with such kind of device compared to previous generation. Last but not least, when you look at the MIA, it's also a huge improvement in terms of power consumption. Compared to previous generation, we are able to save 75% of power consumption in high power mode, let's say having all the resources of the receiver activated. And on top of that, we can even reduce of 65% this power consumption using some special power save modes, which can be tuned according to the customer application needs.
Talk to me a bit about the embedded chip in this solution.
So we do need to worry about size, as Arnaud pointed out. And even though we're worried about making this as small as possible, while we certainly can rely somewhat on the radio, the MIA, improving performance, we want to make sure we still have decent performance from the antenna as well. We want to make sure it's picking up as much signal as it can, even as we reduce our size. Now, in these small form factor devices, you may see going down to an embedded chip solution, for example, smaller than those solutions we've spoken about thus far. It can hopefully fit into your package onto a PCB. It's linearly polarized again, but that allows for it to be much smaller in size, so your footprint is reduced, which can be key. You might be utilizing your PCB as much as possible to pick up that signal strength again. But again, with these devices, especially if it's a wearable, for example, it's not clear what orientation the device is going to be with respect to the satellites at all times. A cat may end up on its back as it's playing. It may end up on its side as it's sleeping. We're doing a balancing act between aspects like polarization and size and radiation to keep an omnidirectional radiation pattern to try to get the best signal we can to improve that received signal as much as possible to assist the radio like the MIA in terms of actual positioning.
Greg, what if a chip can't be made to perform well enough? Are there other solutions?
Yeah, sometimes your PCB may be too small to really effectively get performance from an embedded chip antenna. They're typically very dependent on the PCB ground plane that they are mounted on. Sometimes even the height of the embedded antenna is still too much for some devices, or maybe there's a battery underneath the antenna as well under the PCB. So there are many reasons that you might find yourself struggling to even implement that relatively small form factor, relatively easy to implement solution. There are other technologies you might turn to, even when you're size constrained. A popular one in the industry for consumer electronics is laser direct structuring, also called LDS. It allows you to move your antenna off of the PCB again, sort of like the internal flex solution seen earlier. But in this case, the antenna can be plated directly onto plastic, which saves even more space. Typically, these are custom designs. They're meant to work even when there's a battery nearby, an LCD nearby. It's a very common technology when your consumer electronics device doesn't just have GNSS, but also has other antennas to be utilized as well. It integrates well into a multi-antenna solution. But we've seen these historically utilized for applications like smartwatches, for example. You still have a linear polarization. You still have an omnidirectional radiation pattern. There's some trade-offs there, but it really is a good small form factor and tight package design when something like a chip antenna simply won't perform well enough.
Excellent. Well, I think that's all I have time for today. Thank you so much for joining me, Greg.
Thank you, Amelia, for hosting, and thank you, Arnaud, for your time.
And thank you for joining me, Arnaud.
Thank you, Amelia. Thank you, Greg.
And before we go, you didn't forget to click that link, did you? There you can find even more information about this topic. For Chalk Talks, I'm Amelia Dalton from eejournal.com. For more Chalk Talks, head on over to the Chalk Talk section of EE Journal. You can't miss it, it's right across the top. Or head on over to YouTube, youtube.com/EE Journal.